Almost. All right,
Yeah,
cool.
you're good. It's sharing live on YouTube.
Great. Okay, let's get started then. We're all set. Let's check the chat. Hailing. Susan, where are you? No kidding. Okay, maybe it's going to hail here. Okay.
Susan just sent a text in the chat.
Yes, yes. Onondaga Hill. That's pretty close to here. Maybe I just missed it. I don't know. All right. So today we're going to do the first day where we really start to look carefully at all of the pieces that are in JavaScript. So it's going to be, I mean, it's not going to be nearly as confusing as the first day, where I'm just writing code, or the TypeScript stuff. We're definitely not doing that. Probably again during this whole module at all. But hopefully you got a sense of what those things are, and hopefully nobody is too overwhelmed by it, because it's a lot. But we are going to sort of start moving very methodically now through all of the parts of JavaScript. And this week we're going to cover like the basic pieces, like we talked about variables and values and things like that. The operators that operate on values. We're going to talk some about functions and how to use them, how to control the program with if statements and different statements. And then we're going to go more in depth tomorrow about functions, because there's a lot to functions, and they are very, very powerful technique for doing all kinds of things. And there's a lot to learn about them. So tomorrow is going to get a little more sort of out there, to understand. Today, hopefully, there's going to be a lot of things, but hopefully they're all pretty straightforward. So it's not going to be as fun of a day maybe, but hopefully it won't be as overwhelming either. And we'll have some fun. We'll do a little exercise, and we'll demonstrate this stuff along the way. So if that sounds good, I'm going to get started with yes, definitely ask questions and interrupt. Karen, keep an eye on the chat, please. Thank you. And I'll start sharing my screen. Okay. Okay, so here we go. Present. Oh, and everybody has the slides, hopefully, and can access them. All right, here's day 3. We're going to start looking in depth at the fundamentals of the JavaScript language. We kind of already know what it is, what it can do, a little sense of that. We ended yesterday with this picture, which is kind of like just breaking down the anatomy of a line of code. So, this line of code, what this does is it actually is wrong. I just realized it's actually wrong because it's supposed to be, I guess, the number of states in the USA, and 5 plus 0 is 5. So that's wrong. I don't know. I think I was trying to make it. Wait, let me just fix that right now. I'm sorry. I can't. This is an auspicious beginning. Let's make this 25 plus 25. And let's make this little thing go to here. And this one, make it all line up nicely again. Semicolon. And the expression goes all the way to here. Yeah. As you can tell, I'm a little bit of obsessive compulsive person, which actually helps sometimes when I'm programming. Anyway, back to the presentation. So the result of this expression, this whole thing together, 25 plus 25, is called an expression. This will be 50. And that value, which is what, the value of that expression. Now, each of these are individually number values. the expression itself all comes together to be one value. And that's not written here, but that value would be 50. And that is then assigned with this other operator, the equals operator, to a variable that we name right here. And we declare that it's a constant variable with the keyword const. The declaration itself is the keyword plus the name of the variable. And the entire thing is a statement. So this is, whoops, it's like one thing that the program does. A statement is a step. If we remember, we were talking about imperative programming, it's kind of like a recipe. Each statement is like one step in the recipe. And at the end of this, once you've run this, you'll have the value 50, because these two have reduced to the value 50, that is stored and associated with the name number of states, which is our variable. And now you can't change that. You can't say it's a new number, which actually, if states want to make new states, which they're actually talking about a lot of times, maybe it does have to change in the future. So maybe it shouldn't be a const, but for our program right now, this number won't change. Okay. Okay, so let's start going through very carefully and talk about each of these parts and some more parts that we haven't maybe really looked at in detail yet. Okay, so inside the computer, we kind of skipped a lot of this yesterday, but if you watch the video from the first day, you'll get a lot of the sense of this. The most lowest level parts of the computer that have any kind of software meaning, any kind of meaning in the sense of, computer programs, is what's called a bit. Everything in a computer is made up of binary values. And really, really all the way down at the hardware level, all of the bits in the computer are in fact switches that have power going through them or not going through them. So the computer, like it's incredibly huge number of these switches, and the switches are atomic scale. Literally by now, the computers are a nanometer scale, these little switches, and the switches are on or off, all of them. And so at the lowest level of computing, everything is representable as some number of switches that are either on or off. And those map directly to when we talked about true or false. So in JavaScript, you can just as easily use the numbers 1 or 0, and they will function the same in almost every case. But that's called a bit. That's like the smallest amount of information that a computer can work with or store. And commonly, you'll talk about bytes, and then you talk about kilobytes and megabytes and things like that. A byte is just 8 switches. So a byte is 8 trues or falses all together in a group. And that, allows you to represent 256 different combinations of ones and zeros. So we didn't really look at binary math, and I think I might do this during the office hours if anyone is curious. But basically, if you have one switch, it can be on or off. If you have 2 switches, the first switch can be on or off. And then if the first switch is on, the second switch can be on or off. If the first switch is off, the second switch can be on or off. So you have 4 total values: on, off, on, off. And then every time you add another bit into that, you have another doubling of the number of possible combinations of those switches. And once you get to 8, just trust me, there are 256 possible combinations of those switches. And that's a byte. So a byte is one value, is one possible combination of switches that out of 256 possibilities. And once you have 1 byte, 2 bytes, and you start to get more and more of these, that's when you can really start to represent numbers, words, strings, data, bigger amounts of data. And when we talk about a value in JavaScript, when we say the value 50 or the value of the string red or something like that, we're just talking about some number of bits, some, probably many of them in a particular configuration and then given a meaning. So if your 8 switches are positioned all zeros, and then you also need one more piece of information, which is what is the meaning of the all zeros? If it's a number, then that's the number 0, right? If it's a string, it might be the character A or the character the slides from yesterday. We could look at I actually had the combination of bits. As a matter of fact, let's just look at it really quick and then jump back to here. So oh man, I think I have some slides from last class, which I was looking at for reference here. Okay, this is what I'm talking about. So inside the computer, if you have 8 switches here, and the first one's off, second one's on, third one's off, on, that translates to this sequence of bits if you're looking at them as ones or zeros. And this could be false, true, false, 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 true. It doesn't really matter how you're representing them, but 1 and 0 is a common way to show each one, because it's pretty commonly understood that 1 is on, 0 is off. All of these together, if you look at, if you say, I have these 8, or actually if it's ASCII, it's just 7. But if it's Unicode in the modern standard, if you say I have these 8 switches and they're in these positions, and it's a letter, the meaning of these switches is I want to choose a letter, then that letter is a capital letter A. So that would be the value of these bits. It would be the value that we talk about in JavaScript. It's the value of some data that's inside the computer. So that's a little, this is a little kind of like I'm sort of hand waving and skipping over a whole lot of complicated stuff. It's not really important. Again, what I said at the end of the thing, this section when we skipped this yesterday, there's a whole book that goes into really, really, really low level detail about how you build things. And it's a lot of, it's very difficult to understand everything that goes from bits all the way up to programming language. You don't really have to, it's not common for people who are like their first year of professional programming. It's not common for anybody to understand this. And some people actually never really bother they're like, well, I just assume that it works. And that's actually okay too. So if you're curious, it's worth maybe trying to figure it out, because it is a very interesting subject, in my opinion. But, if you just would prefer to be like, okay, I don't care about the switches, I'm just going to assume that that part of it is just magic, and I will trust that it works and move from there, that's fine too. So that's really all I'm going to say about the real guts of like, what is a value, what is a bits and bytes, or anything like that. Okay. And then back to our thing, the value once you're in JavaScript land, the value here is the number is just 25. It's in your code. You write it as 25. That's it. Or the string with quotes around it, red, red. That's a value. Anything that is just some data plus a meaning that the program should understand that data to be meaning. That's it. A variable is the name. If you take a value and you want to give it a name, the variable is that name. That's all. And we already saw that there are immutable variables, variables that you can't change. That's that you declare with the word const. And there are mutable variables that you can change, and that's with the keyword let. And these two are, again, keywords. If we go back to our thing here, whoops. Come on. That, and they show up as this kind of brighter blue color in VS Code. Okay. So now we're going to get to the operators. An operator is a part of your code that you could say it operates on values. It changes values into other values, or it combines values together. And the first kind, the one that does things with two different values or two different parts of your program is called a binary operator. And that means it works on two things. It just means two. And some of these are like the equal sign, you can say is an operator. It takes a value or expression, we'll get to expression in a couple minutes, on the right of the equal sign, and it binds it to the name that you give it of the variable on the left of the equal sign. So there's two things. There's a value on one side, and there is a variable declaration, or just a variable on the that you've already declared somewhere else on the left-hand side. And again, come on. This is the equals operator in our statement. And what it's doing, again, is once we get the value of this whole expression, it's assigning that value to this variable, or binding that value to this variable. So this is an equals operator. And they get colored like pretty much black, I think. So this is colored very navy blue, dark blue, and operators are black, I believe, in the VS Code, the normal highlighting. Some things are color coded like this for you so that you can kind of tell them apart quicker when you're looking at code. Okay. The plus, I mean, you've all seen the plus. That is a math operator. It's an arithmetic operator. It adds two numbers. In JavaScript, it can also add two strings, which you've seen. You can make hello and world as two strings and put the plus in between, and that operator will combine those two values, those two string values, into one longer string value. These ones are some Boolean operators. These work on true and false values, or truthy and falsy values, values that JavaScript considers to be basically true or basically false. And this is where JavaScript being, if you remember what I said, a dynamic language comes into play, where you don't have to always use true or false literally with these values. JavaScript will just say, the number 0 is basically false. The empty string, a string with no characters in it, is basically false. And it makes all these kinds of assumptions. And we can actually, there's a funny video about this that I should have put in the reading, a very funny video about JavaScript just assuming that types are different types and all the wacky stuff that happens from it. But these are really supposed to operate on things that are, can be considered true or false, and it always produces, it combines the two things on either side, because remember, it's a binary operator. It always works on two different parts. It combines the two things into one value, which is definitely either true or false. The combined value of an expression with this in the middle is always either true or false. Okay, and when I said truthy, this is kind of what I mean. True, the number 1, or any number other than 0, by the way. The number 900 is also truthy. Or an empty object. We haven't gotten into objects, and we won't until, I think, next week even, pretty heavily. But those are all truthy values. And if you put that exclamation point, remember we had the exclamation point where we said the problem is solved and then not problem is solved. It converts anything truthy like that into the value false. And anything that JavaScript is considering falsy, which For example, the key, the actual value false, the number value 0, or a string with no characters in it. Those are all considered falsy by JavaScript, and the not will convert all of those into the actual value true. So the not will not convert 0 into 1. It will convert 0 into true and 1 into false. Little confusing. We're already getting into like how JavaScript just kind of converts things of different types into other types automatically. And that's part of its dynamic nature. And that's a controversial part of its dynamic nature, by the way. It annoys me quite a bit that this language is so popular when it's so it just kind of has all these implicit behaviors, which are sometimes very confusing and surprising. It's one of the things that is probably the worst about JavaScript, in my opinion. You might get different opinions from other instructors depending on, there's a lot of opinions and there's a lot of controversial kind of like arguing about it that goes on to this day. Okay, so plus and minus, if you're using these with numbers, you can actually put just the minus sign in front of a number, and obviously now that's a negative number. You probably all just kind of assumed, well, that's a negative number, but what it really is a unary operator. And sorry, I don't know if I defined this, but unary means it only works on one thing. Binary works on two things. Unary works on just one thing. So if there's just a minus sign and a number and nothing on the other side, it works as like a negative operator. So it turns a +5 into a -5. And you can actually even do plus in front of a number, which won't really do anything because it converts it into a positive, which it already is in most cases. So yeah, these operators are technically unary operators. And one more is, if you want to look at the type of a value, or the type of the value of a variable, you can use the type of unary operator, which actually takes the thing to its right, and it's going to change it into a string that describes what type that is. So I'm gonna pause here. First of all, this is probably a whole lot of confusing stuff. We have plenty more to come, so let's just take a little pause. And remember that a lot of this stuff is like things that I had to look up and write down, and you get the hang of a lot of this stuff just by using it. So don't worry too much about, I have to memorize this and I have to memorize this and this and this and all of this stuff. It's not stuff that you're necessarily trying to memorize all of this. You will probably want to review these things when you are looking at something and trying to remember, oh, how do I describe this part of my line of code so I can search it on Google? My variable is, I want to know what this is called. This is good reference, and it's good to be comfortable with these, but it will come over time. So again, this stuff is not just, you got to memorize all this stuff by rote. And we're just going to play around with some of this stuff now. So we'll take a little break from this and then come back to more stuff after we try out a few of these things.
Mel wants to know if the minus can function as a binary operator.
Yes, of course. So you can absolutely do 5 minus 1. The minus in that case is functioning as a binary operator because it has, 2 values on either side. If you just have -5, that's -5, which is kind of like 0 minus 5, but I don't know. It's that's sort of a philosophical question, maybe. I don't know. Okay, let's go back to VS Code. Oh yeah, and whoops, I was copying this stuff in with the theme, the light theme, so that it would go into my slides nicely. And see, this is some other stuff that but we have a new exercise today also, by the way, which is in a new folder, W6D3 prime numbers. It's just some more math stuff, but it's no tricky algebra. We're just looking at numbers that are prime numbers. We're not going to be doing anything cool or fancy for a while. We're not going to be making dice games or web pages or anything for a while. And so the examples are going to get less impressive for the next week or two. But let me switch this back. Does everybody prefer like the dark mode? It's nice. It's easier on your eyes. Let's see. I can do color theme. And go
Selena likes dark mode.
Okay. I guess I'm going to stick with it. Hang on one sec. I got to get a tissue. Be right back. Okay. So I guess we might as well just grab the code we're going to use later. So if you go to your GitHub desktop and you're in your Careers in Code Classroom code base, make sure it's not a fork. You have the little book here. You want to be on the master branch and then fetch or pull. And if you have stuff here and if it's erroring when you try to click this, you're going to want to do control click on the number of changed files and do discard. I don't have any changes, so this is not enabled for me. So you're going to want to discard your changes. It will confirm. And then you want to click open in Visual Studio Code. And I'm actually going to do it one more time because first I'm getting annoyed that I have so many terminals because our way of opening terminals just opens more and more terminals. And rather than bother clearing them up, I guess you can click this thing a bunch of times. Actually, let's just do this. Click this trash can a bunch to like, it'll speed up your computer a bit, maybe. So why not? Okay, so we're back to no terminals. And you should have this W6D3 prime numbers if you've fetched the latest from GitHub. And I'm going to do control click on W6D3 prime numbers and pick open in integrated terminal like we do so that we don't have to navigate around. Now, what Max posted, I think Karen asked like how to navigate to the folder. Max posted the commands you did learn, the CD command, PWD, LS. Those are good to know. Those are good to practice. And don't think that like I'm saying you shouldn't be using those. This is really just a practical need for this class to have the minimum number of things that can go wrong, because we're just really trying to make this whole remote thing work. And it's very hard to like help everybody who runs into issues. So that's the only reason I'm doing this. Don't read into it like I think this is the right way to navigate a terminal. My colleague Ryan would be like, oh, I can't believe it. You're using a terminal inside VS Code and you're clicking here. You're not typing anything. He's like a real hacker, you know? So yeah, this would bother some people, but you know, we're doing this because hopefully everybody can easily get to a terminal, which you're going to want to make sure it says W6D3 prime numbers and that you have the primes after and before files. And I'm going to close all my files. Let's see. Oh, this is like, that was the homework problem. Yeah, the homework's already in Google Classroom, but you know, stay with the class. Okay, I'm going to click on primes before just so we have it up. But first, we're not going to worry about the code example right now. Let's just click down into the terminal. It's good to know that we're in the right folder for later, but no big deal. I'm just going to type node with nothing after it. And we're going to enter the interactive node. It's called a REPL, a read, evaluate, print loop. And what that really just means is you can type JavaScript code at this caret, just like you can in the browser. Remember, we looked at the JavaScript console in the browser. It's really the same thing. It's running in a different context. It doesn't have the same web, the DOM and the web stuff was things you learn about later, how JavaScript interacts with web pages, but it has all of the basic JavaScript things. So you can do a value like 5, and it will echo back the value of the thing that you type into the so if you do console.log 5, you notice how it says 5 and then undefined. So because we're in a node environment, it is also echoing the value of the whole last thing we typed. And that undefined there actually is the value once you evaluate the entire expression. And we'll do expressions in a minute. But that's why you get two things when you do a console.log in this context. It's because, this allows us to just look at expressions and values and things, and it will bounce them back to us. So if I do 5 plus 5, it's going to take that whole expression and it's going to turn it into 10. And if I do good space and another quote and then plus, whoops, dog, it's going to print back good dog, because it's the plus in this case is working as a concatenation operator. And the two string values that are in this whole expression here are being combined into one string value by this concatenation operator. And then node again is echoing back the value of the last thing you type. And because we're not console.logging it, you only see one thing. I don't know if this is going to make perfect sense to you right away, but the only reason we have the 2 here is because of the console.log. And if you here, let me describe it this other way. I'll make a brand new file. Don't bother, you don't need to do this. I'm just illustrating what I'm talking about. So blah.js, I make a brand new file and I say 5 plus 5. And down here, I will quit node really quick by doing Control-C twice, Control-C, Control-C, and I'll say node blah.js. And nothing happens. And if that makes a little bit of sense, we're in a different context. If I make this say good dog in here, the same thing, it's not going to print anything, because we're not in this loop where it prints the result of the last expression. Node is a little different because every time you type a line, it always prints that value too. And in this context, the program doesn't print this value, so you see nothing when you run it. So if I added console.log here, and I save and I run it, then you see good dog. And you only see it once, and you don't see an undefined, because again, it's not automatically printing the value of whatever expression you have, because it's a different kind of thing. So that's hopefully makes a little bit of sense. But I'm going to go back to just running node from this console that has, if you already see the caret, well, you never exited node and you're fine. If you see this thing, you don't have to do anything. But I'm going to run node because I'm back in the folder here in my terminal, and I have to get back into the node environment. Okay, so what should we look at? Let's see, what should we look at? We have values, we have variables, we have these operators, and we have unary operators. Oh, and we didn't look at the ternary operator. There is one operator in JavaScript that actually has 3 parts of it. And we'll see that in some places later on. But let me get a power cord for my computer so it doesn't run out of power. Oh man, hang on. Okay. Batteries on this one's low too. Okay, so this, I forgot to go to this next slide. There's one more operator that operates on 3 parts. Actually, there are plenty more operators that operate on 2 pieces and 1 piece, but there's only one that operates on 3 pieces. And JavaScript calls this the ternary operator. It's the only one that is a 3-part operator. And it's a question mark is the first part of it, and the colon is the second part. Both of these are together the ternary operator. And the way that what this does is it says, check whether check whether the thing on the left of the question mark is true or truthy enough to be true. And if it is true, this operator will make the entire expression evaluate to the thing that's right after the question mark. If it is false, though, it will make the entire thing evaluate to the thing after the colon. So it's always in the form, check whether this part is true. If it's true, it's this value. If it's false, it's this value. And we can just copy this right into Node. We can actually copy just the expression part into Node. So math random is greater than or equal to 0.5. Is it? If it is, then the coin was heads. If it's not, then it was tails. And this, we can run this expression over and over, and it works like a coin flip. So I can say Command C, and I'll go back to Visual Studio Code, and I'll just paste this right into Node. And it's math dot, this one, it must have been less than 0.5 because it's tails. If you remember from yesterday, this random function is just a way to generate a random number between 0 and 1. So this here is a fair coin because it switches from heads to tails halfway from 0 to 1. You could make it an unfair coin by making it most of the time heads. But just like at the rest of the terminal, you can always press up and return and do it again. And you can do it as many times as you want, and you'll get different outcomes. Oh, we have a lot of heads in a row. There's a tails. Tails, tails, tails. Okay, this is an odd coin. It's doing a lot of runs. But that's this is the ternary operator. So this lets us convert this part into a string that shows heads or tails. And just one more to break it down. Here we have a value 0.5. Here we have calling a function math.random, which is going to give us another number that is from 0 to 1. And then here we have an operator, which is a binary operator, and it looks at this random number and it compares it to this number, which is always 0.5. And if this number is greater than 0.5 or equal to 0.5, then this whole part of the expression is going to evaluate to true. And if not, it will evaluate to false. So this is the ternary operator. We'll get into like, this is technically, this is an expression and the whole thing is an expression too, because expressions are can include other expressions and be nested as deep as you want. But a little confusing perhaps, but that is the ternary operator. You could say true question mark heads tails like this. And this one's always going to be heads because, you know, it's always going to be true on this side of it. You could say false question mark, and then it's always going to be tails, of course. False, 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 tails, 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 tails. So the operator we're talking about is really just this question mark and then this. And that's a weird one. That one's a way out there kind of operator. It's a very tricky one. But, simpler operators are true or false. This one is or. This one takes two truthy or falsy values on either side, and it returns one true or false based on whether either one of these is truthy or true enough. And this one definitely is true. So the whole value of this is going to be true. And we can do the other one, the AND operator, which is 2 ampersands. Sorry, the OR operator is 2 pipe characters. Oops.
Hey, Gus.
Yes.
Carolyn wants to know, is there a way to designate true or false on the other side of the question mark?
Well, so the values on the other side of the question mark can really be anything. They could be true or false, of course. So you could say true, question mark, true or true. And it's true, of course it's going to be true, but it's really this true which becomes the value, because it's this one, it's checking whether this one's true. And if so, it's going to return the value right here. You could say true question mark 50 or true, and you get 50. You could say false question mark 50 or true, and you get true because it's this one.
I meant on either side of the question mark. Like you could do it on the left or the right. Is there a way to like do a true or false?
Well, we just did a true on the right, but the right-hand side, on the right-hand side of the question mark is always the end results of the expression. It's always the end value of the expression is either this one or this one. And the thing on the left-hand side of the question mark is what you're checking whether it's true or false, always. So you can put true on the right side of the question mark, but it's not going to check that true. It's not going to have any, it's not going to cause this operator to work one way or the other, because it's the result of this operator are on this side of the question mark.
It just seemed like, they're all true, so it's almost like pointless. Do you know what I mean? It's like really, really obvious that it's going to be true. So I didn't know if there's a way to kind of mix it up a bit, make it more interesting.
Yeah, well, so this, you usually would never put true question mark and then anything, because if you already know that it's true, you might as well just get rid of this part and get rid of this part, because you already know it's always going to be this one. Is that what you're kind of asking?
I guess that's kind of what it comes out to. Yeah, it just seemed like it was obvious what the answer was going to be over and over and over. So I didn't know if there's a way to kind of figure it out more. So, but we're good. Thanks.
Yeah. I think I kind of get what you're asking. I kind of get what you're asking, and you have some of the words you need to ask the question you want to ask. And I think I get what you're saying. But basically, let me just say one more thing. If your expression is true question mark 50 or 25, or 50:25, well, you might as well just say 50, because this is always going to be 50. This is never going to be 25. Now, if this is like a variable, like if I said, let my Boolean equals true, and then you wanted to say my Boolean question mark 50 or 25. Now, this makes sense. This has meaning, because right now my Boolean is true, and it's always going to be 50 as long as that's the case. But you could then say my Boolean equals false, and then this same exact expression is going to evaluate to 25, because now this is false. So, if there's just a true here, or just a combination of trues and falses over on the left side here, then yeah, it's kind of pointless. But where it becomes useful is when you want to basically store, like for example, we had that is the problem solved flag that was true or false. You want to store something and represent it with a name, and then use whatever the current value in that variable is to cause different behavior to happen, or different values to output from this expression. That's where you'd want to use this. Yeah. Okay, so that's the ternary. The ternary one is always confusing, and I probably should have spent a little more time on the other stuff first. But we do have a bit of time today that we don't have a ton of coding to do, and I want to leave it a little open-ended. So what are people curious about among these operators that we should talk more about? We have variables, we have binary operators, some for arithmetic or strings, assigning stuff to a variable, Booleans. Well, I'll tell you right now that we're going to use this later today, and you probably will need it in the you'll probably need it in the homework, but there's another one called the modulo operator. This is a weird one that we don't usually see in normal arithmetic, and it's sort of like a remainder. So you could say 5 modulo 2. And does anyone have a guess what the result of 5 modulo 2 is going to be? Oh man, there's so much chat. Where's Karen?
It's 1, right?
Yep. How did you get that?
Well, because I read it. It's earlier. I read the thing you said. 5. It's the remainder. So it's like 5 divided by 2 is 4, and then you subtract 4 from 5, and you get 1. Is that right?
Yes. So that's 1. And that's because it's not exactly the remainder, because you can actually do negative modulo. You can say -5 modulo 2 or 5 modulo -2. And that doesn't really mean anything in remainder speak. But modulo, you can do that. I honestly can't even tell you what that means. I don't really use negative numbers. So it is different from remainder because it has some meaning with negative numbers, which is super confusing. But for like positive numbers, it's basically the remainder in division. Yeah, so you can say 6 modulo 3. And it's 0 because 3 divides into 6 even number of times. 3 times 2 is 6. You can do 6 modulo 3.3, and it's 2.7 because after you take away 3.3 from 6, you just have 2.7 left over. Yeah, that makes sense. So you can do it with decimals. You can do it with, numbers that don't divide. Modulo 4, that's 2. So that's another binary operator, which you're not normally used to from arithmetic. Obviously, you can do 6 /4, which is division. That's 6 divided by 4. And that's 1.5 because 4 times 1.5 is 6. Or 6 divided by 3, that's 2. And you'll notice that every time the division between two numbers is an integer, so 6 divided by 3 is 2, then 6 modulo that same number is going to be 0 because it divides evenly.
Okay, so Elena wants to know how, and Carolyn wants to know if you're saying modulo, modulo.
Yes.
Oh, I don't need to know how anymore. I get it after seeing it.
Okay. Fabelia, do you want to pause a bit and you're not seeing any code when you open the JS file, the new one?
No, it's showing us blank.
Blank meaning you don't see any code. You don't see any of this here in the window.
No code.
Okay. And you've definitely gone to GitHub Desktop and fetched?
Yes.
Okay. And then you've definitely, you're opening the same folder. I guess you couldn't have gotten that. Could you share your screen really quick? We can get that fixed.
Oh, sure.
You need to stop sharing, Gus, so she can share. Sorry.
Sorry, I'm, yeah.
Whoops.
And yeah, what else am I missing with these operators? We'll do some unary operators like the negative operator. And we'll look at the type of operator because that's a weird one. it's not familiar probably. But if anyone while you're waiting, try typing the word type of, TYPEOF, space, the number 1, and see what that shows you.
Oh, okay, here's my screen.
In
Okay,
the terminal or in our code, you want us to type that?
If you're in the node terminal with the caret, with the angle thing,
Okay.
just type it right into that terminal. Yeah, see what
What
that
was it again?
TYPEOF space 1.
Thank you.
Fabilia, okay, try clicking open in Visual Studio Code there. It's to the right. Yeah, up a little to the right.
To the right.
Yes.
Okay.
Oh. And yeah, so try clicking on primes before, double clicking on primes before there.
Primes before
Yep. Primes.
primes. Okay, right here.
Yep.
Double click.
Yep. And you're all set.
Oh,
Now, the terminal, you're going to want to control and click on the W6D3 part to the
okay.
left, in the left page pane. Up more.
Nope.
No, up. Move your mouse up. Yeah.
Oh,
Yeah.
okay.
No. That's scrolling. Scroll down. Okay, stop. Just move one finger on the trackpad. Down. More down. No, you're still scrolling.
Oh,
Like you're
no.
using
Oh,
two
I see.
fingers. Yeah,
Okay.
yeah. That you're almost there. Okay. So just move over to W6D3.
W63. Oh, okay.
Yeah.
Right here.
Yes. And then
Okay.
hold the control key on your keyboard and click that. And do open in integrated terminal. And now type and maximize this window. Make this big, fill the whole screen, because this is yeah, double click that. Yeah. Okay, and now click down in the terminal and just type node, just the word node.
Okay.
Yep, and hit enter, and then you'll all be all set. Okay, so now you can do the same thing. Type of TYPEOF.
TY.
PEOF. And then space, and then the number 1. And hit enter. And it tells you right away, the preview there, that the type of operator takes a value and it turns it into a string that describes what JavaScript thinks the type of that value is. And we can actually go through types.
Thank you.
Yes. Could you stop sharing so I'll get back? Oh, I forgot to cover. I don't think we have covering types today. I think we'll do types tomorrow and then jump right into functions. But JavaScript, the things I've already been talking about are types. A number is a type. A string is a type. Objects are types. We haven't looked at objects, but they're the curly braces on their own. Square braces on their own, like a list. Like we have the list of dice. That's an array type in JavaScript. And there's a couple others. There are not that many, but they're basically the meaning. Again, like I said, it's the meaning that you assign to that data together to give you a complete value. And the type is basically the meaning of the data you're looking at. And meaning in a sense that only the meaning to the computer. Obviously, if you've named that in a variable and it has meaning in your program, that's a different sense. That's not what I mean. Some of the stuff is a little hard to talk about because it's very, the English words are not great, but yeah. Okay, let me go back to sharing. Because we are back on operators and we just want to make sure that we are covering this stuff and answering any questions you have. So this is an interesting unary operator. Type of space 1, that's number. If I do type of space dog, does anyone know what that's going to be? I guess you can all do it and then tell me.
Latonia says a string.
Yes. So it's the string that says string. It's a little weird, but all the results of this type of operator are going to be strings, but they will tell you what JavaScript understands the type of this value is.
I got undefined for dog.
Did you do type of just dog with no quotes?
Correct.
Yeah, so that's because you have no variable called dog.
Correct.
Yes. And it's looking for, it's basically saying the meaning to JavaScript is, oh, I'm looking for a variable called dog. And you've never described, you've never said what dog is to JavaScript. So it rather than error, rather than saying error, dog does not exist, JavaScript just says, well, that's undefined. We'll just say that's undefined, and that's good enough. So it sort of tries to just skip over what probably should be an error.
But the single quotes will bring it back and say it's a string because you're trying to define what that would be, not in any relation to the code that you have above it.
Right. Now,
Okay.
if I say const dog equals function here, and then open this and say console.log woof, don't worry about following me, but now if I do type of dog, it's going to say function because I've defined dog. It's no longer the type of this keyword dog here is no longer undefined because I defined it. And now the type of dog is the same as the type of what I assigned to dog, which is this whole function, which is probably confusing to some people, but I can just for academic purposes, I can also say type of and paste that whole function that I did. And that's also function. So this is a weird operator, and you don't use this very often in like basic kind of programs. But there are times where you want your program to understand whether what it's looking at is a string or a number or an array or an object or a function or other things. You can do type of null, and this is a special value in JavaScript, but for some reason null has the type object, which is weird. It's the same as type of this thing, this empty curly braces. That's also, for some reason, the same kind of type as null.
Shah would like you to do a Boolean.
Okay, type of true. Boolean. If I do type of Boolean, what do you think that'll be?
True or false?
Undefined?
Boom, undefined. Because that doesn't even make sense. That's not a keyword in JavaScript. And so it's assuming that's a variable name, and the variable doesn't exist, so it's undefined. If I do type of Boolean like this, it's a string because this is a string. So this is a way to, if you want to check, what you've stored in a certain variable, you can always do let x equals 5, and then you do type of x, that's a number. But if I do now x equals dog, type of x again, now it's a string. Okay, I think we can keep going. And I want to figure out what is a good place to break, but let's do let's get to control flow, and then let's take a break. And then I think we really, we have some more lecture stuff, and then we'll do a short exercise today. It's mostly lecture today. Okay. Ternary operator. There's that. Okay. Expressions. We already talked about this a lot. I've been using the word expression. And let me just really quick jump back to this thing. The expression in our line of code here is all of this. So from here to here is what we call our expression. And it's like more than one value that all kind of ends up becoming one value. Yeah, an expression is any valid unit of code that resolves to a value, one value. And this is some random website I pulled this from, but an expression is any valid set of literals, like the quotes with dog in the middle, that's a literal string. That's what that's called. Variables, so like when I said let x equals 5, x is a variable and its value is 5 at that time. Operators, that's the plus in between. So 5 plus 5, it's a valid set of all of those things together. You can say function invocations, which is like math.random. That's calling a function and that produces a value. And more expressions. So you can say 5 plus 5 plus 5 plus 5. The first 5 plus 5 is an expression, and the whole thing is also an expression. So an expression can have nested expressions inside of it, which is very confusing to think about, because you could have an expression that's thousands of lines of code long if you had a big enough expression. But it all has to basically evaluate down to one single value once you calculate what all the pieces are. Conceptually, there's two main kinds of expressions. Most of the ones we look at, or when I say expression, most of the time what I mean is the second kind, the ones that simply turn into a single value. So like this one, true and false, that's an expression. The value of this, once you evaluate, is false actually, because it's like true and true. The value of that is true. So you can replace this with true. And then it's true and false, which is only true if both sides are true, and this one isn't. So the whole thing is false. This, good plus dog. This is two strings being concatenated by the concatenation operator. That's an expression. 5 plus 5 is an expression. Or 5 plus, this is how you do 5 squared. There's the math thing, the same thing we use for random, also has a power function, which is 5 to the power of 2, which is the same as 5 squared. So 5 plus 5 squared, once you evaluate this, or once you run this whole function, it's going to return 25 because that's 5 squared. And then that will be added to 5. So the value of this whole expression, it will become 30. And then the other kind that they just mentioned this for academic purposes. I don't really normally see this being used as this kind of thing is even discouraged. You really don't want to just say a line of code x equals 5 plus 5 unless you first defined x. Because one of the really tricky traps in JavaScript is that if you don't put a const or a let first, the first time you use this variable, then this becomes a globally scoped variable, it's called. And this means that everything in your entire program can see it. And that's a problem because you might use X somewhere else in your program and you only want it to be defined in one place. So like this, I'm only mentioning it here because this is part of the academic definition. It is also an expression. So x equals 5 plus 5. Let's do this in, whoops. Oh no, this is my work. Yeah. X equals 5 plus 5. X equals 5 plus 5. And actually we've already defined X, so we're good here. We already defined X. So it's not going to become a global variable. It doesn't matter in this context because we're just in the node loop. Like we're just, everything's global here technically. So no big deal here. But the value of all of this as an expression is still 10, and it also has been assigned to x. So x now is still 10 too. So this expression evaluates to 10, but it also has what's called a side effect. It also does something outside of it just becoming a value. So that's a little weird. This is technically an expression. I think if you say const y equals 5 plus 5, I don't think this whole thing is a expression, but I'm not even sure. And who cares? When I'm talking about expressions, I mean like stuff like this. I'm never going to be saying expression and, oh, by the way, it's an assignment expression. That's just some academic thing that really never comes up for me. So, you know, don't worry about it. What you want to take away from this is, what? Am I like in the wrong window? Oh, geez. Okay. So there's another window here. What you want to take away from this is an expression is like a combination value. It's stuff that has more than one part to it, and that all will be able to be turned into one value. And just like I said, this becomes good space dog, this becomes false, this becomes 30, this becomes 10. This also becomes 10, but it's weird and who cares? And that's really all that an expression is. It's like a compound of more than one value that all turns into one value. And it can have all kinds of stuff like calls to functions right here. Okay. Yes. And this is actually not even correct, because I just said the assignment expression, this one has a side effect. It assigns it to x. Expression evaluates to a single value, but now I'm saying it doesn't have any side effects because clearly I'm confused about what an assignment expression is. But basically, expressions don't do anything on their own. The way I use the word expression, it just means that the thing that combines to a value, and it doesn't really do anything on its own. Unless maybe you call a function that has a side effect or whatever, but usually what you're talking about just something that produces a value. A statement is like a whole line of code. It actually causes the computer to do something. So let me illustrate this. If what I mean is I put 2 plus 2, that's an expression. It doesn't cause the computer to really do anything permanently, or it doesn't cause your program to do anything. You can drop this in the middle of any program you want, and it won't have an effect because it's not the computer will evaluate it, but it's just an expression. It doesn't do anything. In order to get the computer to do something, you need to make it a full statement. So like a full statement is, let my other number equals 2 plus 2. That does something. And this actually has so yeah. Watch this. See, when there's the let there, that whole statement does not evaluate to any value because it's not an expression, I guess. I don't know. This one is an expression for some reason. This is how JavaScript works. This is that weird assignment expression nonsense. But both of these are different from just 2 plus 2 because they have a side effect. If I go later on and I say my other number, that has changed. That has actually been set to a certain value. So the computer processing this bit of code has actually caused a permanent change to happen. Where when you tell the computer to process, 6 or 7 plus 5, it hasn't caused anything permanent to happen. It prints out, it echoes back the value of this expression because we're in Node, but it wouldn't if we're in a program like this. It wouldn't do anything at all. And I think some browsers might even just delete it when they go to run your program, because they'll be able to figure out this has no effect. It's just an evaluated thing which isn't used. So they would just skip running it entirely, possibly. So that's sort of the difference between just an expression and a full statement, which causes the computer to do something that is going to be useful. Does that kind of make sense? A little bit, a lot? Check the chat. Okay. Okay. Melikwan, so in the example in slide 2, why isn't number of states part of the expression? So yeah, let me just, yeah, so you're talking about this, or no? Yeah, okay, so you're talking about why doesn't the expression line cover all of this all the way to here, right? And I'm not really sure. It's because I don't like thinking of this assignment, and it may not be. Honestly, I'm not sure. And I'm not sure how many people even could answer this, because this is like a very esoteric academic question. Like, if you're looking at a statement, a full statement like this, is just this part an expression, but this turn, the fact that there's a const here definitely means it's not a normal assignment expression. And I you know, we're getting a little in the weeds here with like this concept of assignment expression. I don't think it's really that useful. Yeah, I think it's because it really isn't an expression, because the const is here, because you're declaring the variable too. And this whole thing evaluates to undefined, as we see node prints out that undefined when you do it. So like, it's not really an expression. I don't know. I don't consider it part of the expression. And if I am talking about your program and I say that expression there, I'm never going to mean this. I'm never going to mean something being assigned to, because that's just silly. I don't know. That's confusing. It's very, so I don't even know the answer to that question. And sorry. Yeah. Yeah, const is a keyword, which is going to mean that you can't, yeah, you can't then later say number of states equals, 30, because it would say you can't reassign. And I'll show you that real quick. If I say const number of states 50, say number of states 30, it's going to error. Type error, assignment to constant variable, which sounds a bit like an oxymoron when you think about it. A constant variable, but that's what it's called. Okay. So let's see, what else do we have before the control flow section? Okay, that's it. Do people want to take a break right now, and we'll come back at like 7 or 7:05 or something like that, and we'll get into control flow, which is going to be, by the way, if statements, and you've seen some of these already, but we're going to go through them formally. So let's say meet back here at 7:05. Cool. And yeah, if anyone has problems with VS Code or questions, I'm gonna just be hanging out here. I'll put on some of the jazz music. I hope everybody likes that. I actually like it, so it's not just a joke. Yeah, I think it helps, and we can do breathing exercises too while listening to jazz, and we'll all just be so ready for the more programming.
I almost was going to tell you earlier, okay, you need to do your circular breath.
Yeah, yeah. No, I get out of breath. Like, this is actually, I'm doing pretty well today, but speaking for, yeah, I'm not used to speaking at length like this. I definitely don't do this in my job,
Yeah.
and it's a skill. Wow, Carolyn, you went to Berkeley in Boston, right? I had a high school classmate who went to Berkeley and now is like in the music industry, producing for like One Direction or something, like all kinds of stuff. Yeah.
That's impressive.
Yeah.
Yeah, my husband went there too, but he's 4 years older than I am. So we didn't meet there. We met later. But, we each only went for about 3 semesters. It's the kind of program you come to realize pretty quickly whether it's going to be a practical way to live or not.
Yeah.
And I was not going to be the next Carly Simon or Joni Mitchell. I wanted to be.
Yeah. What did you go for? Did you go for like vocals?
Vocal performance, yep.
Cool.
Yep. And I still sing with the Syracuse Chorale, but I've had to lay back these last few weeks as they prepare for their virtual concert because I just don't have time to work on the music too. So, yeah. Very cool. That was back in 1979. Oh, I just dated myself.
That's cool though.
I was 6.
Oh, I was 18. My birthday's coming up this weekend and my son's is as well. His birthday's on Saturday. He's gonna be 19, and my birthday's on Sunday, and I don't mind sharing, I'm gonna be 60.
Hey, congratulations.
Yeah, that's one of the things this program hopefully will help with.
Actually, I have a child that's older than Max, definitely older than Ryan because he's so young. And she might even be older than you, Gus, but I'm not sure about that. And she's older than Jesse.
I was born end of 1988.
Oh, no. Nope. She was 92. So she just turned 29.
Okay.
Wow.
Yeah, Ryan is like, he was barely alive during the 20th century. Like,
he wasn't even 21 when he taught us. He was
Wow.
19 or 20.
Yeah, he's 22 now or 23, something like that. Yeah.
These child prodigies among us, like our son, he did some of the hackathons, and that's how I learned about boot camp back in the day and everything. And he's at Clarkson. He went to the Clarkson school, so he skipped a year of high school and started college the year early. These brainiacs. I don't know what I'm doing.
Yeah. College was all right. All 5 years of it. I finished in 5 years.
Was it computer science or?
Nope. My first 2 years I was doing computer science, but yeah, I was a train wreck in college. I was just like, who cares? This is so silly and blah blah blah.
That's not unusual though.
Yeah.
Can't regret it. You just move forward.
You and Ryan do a lot of different stuff other than programming too.
Yeah, I mean, I can grill a mean steak. No, I play a lot of music too. I can do all kinds of stuff. I've been working on vocals too. That's a hard one to do. It's very difficult.
I
know. Caitlin and I have to get together with you too about.
So here's some bread, okay? And some peanut butter.
A theme song for the podcast.
Oh yeah. Yeah.
So what do I do? I'm a computer. What do I do?
Open the jar and dump the peanut butter onto the bread. Actually,
in the jar with my fingers, because I'm the only one that eats this kind. That was really funny yesterday.
Yeah, I'm glad you enjoyed it. I was like, I don't really know what I'm doing like with that. I've heard about that before, and I was like, oh, this is actually a good idea,
Yeah, well, no, it's is that called chunking when you break something down like that?
Yeah, I mean, I don't know if there's really a name for it. It's programming. I mean, it's really the essence of programming. It's that kind of
Right.
thing. It's kind of like saying, "Oh, I need a random dice." Oh, what does that actually mean? Well, first I need to get a random number of the right kind, and then I need to transform that into a random dice of the right kind.
But you're breaking down, you're taking, when I studied special ed, we learned it's called task analysis. And it blows your mind just how many little steps there are in the things that we do and don't think about that some people, and so it kind of made me think of that a little bit. It takes you an hour to make a sandwich, but
Yeah, yeah, and yeah, that's true of human processes too, of course.
Yep.
Yeah.
So I know it was computer programming you were demonstrating, but I couldn't help but think, some of the clientele that I had years ago.
I mean, another example is
Break it down.
another example is when I say, go to your VS Code folder. Like, and I think, oh yeah, go to your VS Code folder. And there's so much packed into that. And somebody who isn't familiar with like, what is a folder? What does a folder mean in the context of VS Code? What is, are you talking about the left pane that has this stuff? There's so many details that are embedded in that.
Yep,
And,
some of it assumes that you've, used computers before, so some of the stuff is familiar. But and then you're trying to help everyone whose GitHub is crazy, and I appreciate your patience and all you're doing. I gotta get some milk, I'll be right back.
Yeah. Yeah. Check my work messages. Please review this code. Oh, okay. Later.
Well, I just thought of something, Gus. I know we're going sequential from day one, but the homework I did hand in, since it's the first homework for this, I numbered it as homework 1.
Oh, okay.
Which it doesn't show up that way in the Google Classroom, but
as long as if you attach it to the right assignment, that's
oh
fine.
yeah.
Oh, and I forgot. I said I was going to go over the yesterday's homework today, just really quick.
And then
Yesterday's homework was more of a creative homework. It's not supposed to be very difficult. It's just like, trying out different ways of representing the problem. What do you want to name things? That's really
so you get the same results, but I didn't see any code for that first one. That's what kind of confused me.
Yep.
That was on purpose.
Well, you're supposed to take the code from the exercise is really the secret to that one, is to read that.
For last night's homework?
No, not last night's homework.
That's what I'm talking about. The one with the number of seconds in a year.
Well, technically, there's one line of code in the assignment. It's like
that is
line of code.
But then we're supposed to come up with more.
Yeah, tonight's assignment, there's no code. It just says, what should it show? What should it display?
I should run by what I've done so far, just guessing, not really knowing what I'm doing.
Yeah.
When is everyone coming back? In a minute or two?
Yeah, a couple minutes. Karen, yes, you're right. It's a good analogy too.
Screen share it if you want to see.
Sure. Karen, yeah. It's like if you learning to drive a car is kind of like learning to write functional JavaScript in a way, even because you don't necessarily know how everything under the JavaScript is working, all of the little switches that are flipping back and forth inside the computer chip that are microscopic. You don't know all that stuff, but you're still operating the JavaScript language. And then obviously you can make a website that another person can learn how to operate your website, but they won't even know what the JavaScript code that goes into it. So it's layers and layers and layers of this kind of stuff.
Oh,
For sure.
I deleted the homework that I was working on. I bet it's somewhere though, because I was trying to figure out const, and it's like, if this, then that, because you've got to account for leap year. There would be more seconds in leap year than.
Yeah, your spoilers. Did anyone else account for a leap year in their homework?
I don't know, but I don't even know if my code is good, and now I don't know where it is because I think I dumped it, so I had to find it.
Here's a question, Carolyn. Do you know how to determine if a year is a leap year or not?
It has 366 days.
No, but if I give you like the year 2021, how do you tell whether the year I give you is a leap year or not? Just the number, the year number. Is it a leap year or not?
It's every 4 years. I never really paid that much attention.
Yeah, it's pretty much every 4 years. There's some tricky rules to that.
But if you look at the numbers, the numerals, whatever, in the year, that is kind of a giveaway too.
Yes. So I guess we'll wait until everyone gets back, and then let's just review the homework and talk about some different ways of approaching it. Because this is actually a pretty interesting homework. It's like very simple if you want it to be, or it can get pretty tricky.
I have a question, Gus, about our homework for tomorrow
Sure.
or Sunday, whatever day is due. Are we going to talk about that directly at any time during this class, the whiz, was, whatever?
We're going to do an exercise with prime numbers that has some similarities about seeing if stuff is divisible by other numbers. So you're not going to be going into it totally from scratch, but I do want to leave it like so that there's no starting point, other than we're going to learn some of the things you would need to apply, like checking whether something is divisible or not. We're going to learn some of that today in our exercise. So hopefully we have time to get to the exercise. I think we'll have time. We'll be good.
Where did I put it? Yeah, I was thinking I was on the right track, and now I don't know where it is.
That's fine. Okay.
Can you
I think
cover something in Visual Studio Code?
Maybe, but whatever.
But
I mean, you've lost work before, right? It's a bummer, but
it's a baby though.
Fine, you'll be fine. I owe Dana. Thank you for reminding me, Karen. I owe Dana when I'm going to do my office hours because she's supposed to schedule them. So what do people think about when should we do office hours this weekend? Is it usually Saturday everybody likes?
Yeah, we've been doing Saturday 10 or 11 because we have our career meetings on Fridays usually.
Okay. Does anyone have a problem with Saturday at 11?
That's generally when they have been, but usually it's whatever the instructor is available. Oh, when the instructor, oh my God, I can't talk. When the instructor is available.
Okay, we're going to do Saturday at 11 a.m. then. I just told Dana and she'll put it in the calendar.
Yeah, and then I'll put it in Slack tomorrow night after class too, just to remind everybody. And then again, I would like Friday or Saturday.
Sounds good. Okay, let's check out some homework from last night just for fun because this one was an interesting question. It was the number of seconds in a year. Just print that out, and that was it. I'll just do a little coding here. Why not? Whoops. I'll make a new file. So I control click here, new file. You don't have to do this if you've already done the homework, of course. Homework.js. And I'm going to quit Node. So I'll click down here to the terminal, do Control C and one more time. And in my homework file, I can basically say const this is the normal way a lot of people might have done this. Seconds in a minute is 60. Const minutes in an hour equals 60. Const hours, so you start with a lowercase, I guess, in a day, 24. Const days in a year, 365, normally, not on leap years. And then you do console.log seconds times minutes times hours times days in a year. And I'll break these onto new lines, I guess, because why not? So this is the most kind of normal way. This is like the default way of doing this. And if you do node space homework, we get our number that we want. Hooray. Now, there's a couple things about this, and that is that 2020 had 366 days in it. So it kind of depends on the year that you wanted to do. 2020 had this number of seconds in it. And the homework was a little tricky because I said it's a program that prints the number of seconds in 2021, but your program should print the number of seconds in a year. So, well, I don't know. That is a little more confusing. It's like not sure what that should be. And in order to do that, you pretty much have to allow the person to choose the year. So one way to do that could have been this whole thing that we had from here, require this prompt sync. And you don't have to follow this, but you know, if you made a prompt and you asked the person const number year equals sync which year, question mark, space after it. And then you can say, parse int. So you want to turn that into a number. And there's a special function in JavaScript called parse int. You're not expected to know this. And by the way, you're still going to get full credit if you did it this way. I'm just showing you some fun variations on the problem. I slacked myself. This is how you tell whether a year is a leap year. I found this on the internet. Actually, every 100 years is not a leap year, except for every 400 years. So I got this function from the internet called I'll name it is leap year. And this is using our modulo operator and our ternary operator to say, is the year evenly divisible by 100? If so, it's only a leap year if it's also divisible by 400. Because that's the rule. That's apparently the rule. If not, then it's only a leap year if it's divisible by 3 or by 4. Sorry, 3. So this is really funny because the year 1900 is not a leap year. And I think the year 1600 is a leap year. 1700 is not, 1800 is not, 1900 is not, 2000 is. So that's one of the 400 years. 2100 is not a leap year, but like 1904 is a leap year. So it's normally anyway, this is truly how to tell whether something is a leap year. So you could say days in a year equals is leap year, question mark. If so, then 366. If not, then it's 365. So now when I run it, it's going to say module not found because we have to install this prompt thing from remember all this nonsense. So I'm going to say npm install prompt sync. And now I'll try it. Which year? 2021. Boom. Do it again. Which year? 2020. It's different. So this is what, this is like the full solution where it works for any year. And I'll paste this into the pasted code if you're curious. Yeah, and you want to try that. But that's a fun little variation on the homework. Remember, you also have to run npm install prompt sync to get the right package you need. And we'll get into package managers later. Don't worry about if this is totally makes no sense. This part is this weird npm stuff that's new to you. We haven't covered it yet. So yeah, that's like a really good solution. Now, here's another solution, by the way. You want to see one more? We'll say which year. We don't need to say is leap year. We don't need any of this calculation. We can say new date. And then let's see, value, year, month, date, hours, minutes, seconds. So we'll say year 00. Let's see, const start of year equals new date of the year 00, and then 0 months and 0 days. And date is just a built-in JavaScript thing. It has some date thing. It's called a date. We do const end of year is new date. Now this one is year plus 1, 0. So this is when the next year happens. So midnight of the year right after. So it's basically the end of the year. It's the same instant as the end of the year. And then you can say, oh man, let's see. How do you do a date into, let's see. Let's just see what happens if we do console.log end of year minus start of year. Because this might work. I'm not actually sure what you can do with dates exactly, but there's some way to get the seconds from these. Which year? 2021. Oh, we're close. But look, there's 3 extra zeros. So when JavaScript says, oh, I'm doing minus, I'm doing subtraction on date, so I need to convert these to numbers. What it actually converts, the number that it actually converts to is the number of milliseconds in a year, which is, there are 1,000 milliseconds in every year. So we need to wrap this in parentheses and divide it by 1,000. And then we got it. 2021, there's the number of seconds. 2020. So this one, I'm pretty sure nobody got even close to this one. This is a real tricky version, but it's actually shorter and you don't have to do any multiplication. You can use the built-in date stuff. And you don't have to worry about leap year math because it's all built into this date thing. So I'll paste this in too, in case anyone wants it. All right, enough of this homework stuff. I just gave you 2 amazing answers to the homework, and don't worry about, your answer can be anything. It's really just a creative problem. So again, just, try, think about it, and you can name, the exercise is really about naming the variables, seconds in a year, or sorry, seconds in a minute, and so forth. Anyway, that's the homework. You pause, check the chat. Okay, back to the lecture. How's everyone feeling? We refreshed? Was that homework was a bit of a, it should be relaxing, but my solutions are probably slightly confusing. Oops. Cool. Okay. Yeah, and tonight's homework, if you get stuck on it, that's fine. Try it a couple times, reach out for help. But it will make more sense if you wait to try it until the end of class. So, yeah. All right. Control flow. This is our next piece of JavaScript basics. So JavaScript has keywords. Remember, we talked about const is a keyword, and let is a keyword, and type of is actually both. It's like a keyword, but it's also an operator, and they're colored. I guess this looks like a different color scheme from before when I don't know, but they're colored a special color. And if, else, they jump out at you. These are keywords. Let, I guess that's a differently colored keyword for some reason. I don't know. I'm pretty sure that's a keyword though. That's also a keyword. So these three are keywords. The control flow, the idea of control flow is that while our program is running, one of the requirements for, if you remember, I said a language to be Turing complete, one of the requirements for something to be able to compute anything is that you have to be able to take different possible paths depending on what the results of your program are while it's running. So control flow just means that while your program is running, you're going to do this, or you're going to do this, or you're going to do this thing over and over several times. It's basically controlling which direction the computer goes to execute the next thing. You need to be able to sort of direct the computer into its next instruction that it should execute. So the first one that a lot of people learn is what's the if statement and the else statement. Now, an if statement is basically saying that it should look at some condition inside these parentheses. And this had better evaluate. Remember, we talked about expressions and they all evaluate to a value. This had better be a value, or it had better evaluate to a value that is either true or false, or truthy or falsy. And then based on whether it's true or false, this stuff inside the if statement will either execute or not. And you can actually have, hold on. You can actually have an if statement by itself. You don't need this part for it to be an if statement. What will happen here is that the code inside here is only going to execute if the random number we generate, that's here, it's between 0 and 10, because if you remember this random stuff, this is between from 0 to 10, any decimal numbers, anything. But this code inside this block here is only going to run if the condition inside this part here is true. And we're using the greater than operator. It's just like another mathematic operator that's going to, it's a binary operator because there's something on this side and something on this side, and it combines them into a single true or false value. And if that's true, this code will run. If it's not true, the code will not run. And because we're doing this randomly, sometimes this will run and sometimes it won't. And I'll copy some of these examples right into VS Code and I'll show you them. All right, so I'm going to make a new file, call it examples. And I'll save this. I'll run node examples. And nothing happens because whatever number it was must have been less than 5. We run it again, the number is large because it was greater than 5. So this way we're actually randomly controlling the path that the program takes, which isn't usually a great idea in the real world, because it means you might get bugs that only happen sometimes because they're depending on random things. So this might not be the best example for me to show you, but it's a cool way to just demonstrate, and we can see that it's either taking this path or not. Over and over. See, sometimes it's large. We can also console log my number each time, no matter what. So we'll be able to see exactly what it's checking. So this time it's not large because the number is tiny. It's 0.11. This time it's 1.8. Still not big enough for this to be true. Almost. And I'm not designing this. I didn't do this. This just happens to be, come on, big number. No, smaller. Okay, here we go. 5.8. And because it's now, this is big enough, this will be true, and this code will run. And the original one of this is we add another keyword here called else. And then the block right after else, this is going to basically be a fork in the road that your program takes. It's going to go one direction, or it's going to actually execute this thing here. And then, by the way, the program continues after in either case. So we can say console.log all done. And the formatting is really odd here, but it should work if we copy this. Oh, my quotes are weird. They're Google presentation quotes. So no matter what, at the end, it will say all done. Uh-oh. My number has already been, oh, whoops. I left some code up here, and then I tried to declare my number again with another let, and it doesn't like that. It said, you can't declare it twice. It's the same thing. Okay, so I have to delete all of the old code here. So my number is large this time, and then always is going to say all done. So the same is true, obviously, of here. If there's only an if else, or if there's only an if statement, it's always still going to say all done, all done, all done. Now it's large and all done, but this it always continues after the end of your if statement. That's all I'm saying. So if and else are basically two options. If whatever is here is true, it's going to do the first thing. If whatever is here is false, it's going to do the second thing. And then it's always going to do the third thing. And I'll have it log the number. We'll just do that a couple times. 2.2 is small and all done. 0.7 is also small and all done. 6.2 is large and all done, and so forth. Hopefully this makes a lot of sense. And let me clean this up a little because I think this is live on the internet. You know, this is like, oops. Okay. Now, there's one other thing you can do with if statements and else statements. You can have a third option, or in fact, as many as you want, in between the first if and the last else. And this is called else if. And it's just going to check each of these things in order. So this is the same setup, but this time it's going to say, evaluate this. Use this operator on the two sides and see, you know, is my number greater than 7? If that's true, it's going to run this. If it's false, it's going to go to the next thing. And because we have another one in between now, it's going to check a second time. Use the operator, is my number greater than 3? If that's true, then it's going to do this one. And if not, it's going to go on to the next one. And because all we have left is an else, it's going to run this. So you can use this to check many things and only run one of these possibilities, because all of these are in the same set of if, else, if, else. It's only ever going to do large, medium, or small. So we'll run that. Large, small, medium, small, medium, small, small, and so forth. And again, obviously the afterwards, it continues on just like before. And now you can also remove this one. And this will only print large or medium if it's neither of these conditions. If both of this is false and this is false, it's only going to print done, because it's going to finish without any else. There's no catch. There's nothing to catch all of the false, in the condition, in the case where everything you're checking is false. That's what the else is for. So if you leave that out, you can't do it. Now you can't start something by saying else if. It already knows immediately that's not even valid. And you definitely can't do just else, because that doesn't make any sense. The else always has to come after the first one being just an if. So the last thing is that you can do another thing. You can say smallish, maybe if it's greater than 1, and then it would be tiny. So you can put as many else's in between as you want, and it's still only going to do one of these 4 now. So smallish, large, medium. I don't know if we'll get a tiny, because that's not very likely. Oh, tiny. So 0.7. That's tiny. So hopefully this makes sense. I'm not going to spend too much time on just the if statements, because you'll get the hang of all of these actually just by using them. But the if, that's the most basic one to make your program, decide whether to do something or not, or to have different kind of surprising behavior. And that's usually where the interesting parts of a computer program really happen, is, where the program actually decides to do a different possibility. Okay, another control flow loop. We've already seen this one too. This is a while loop. So this runs the same code inside here over and over and over. But first, each time it runs, it checks that this is true. And if it's true, it runs it again. Or it runs it the first time. It checks the first time too. So if it's false the first time, it never runs anything. But it checks if it's true. Inside here, it runs. Then it does it again. Checks if it's true. If so, it runs. And then if it's ever false, it says, okay, done. And it continues. And that's it. So here's an example where we make a mutable variable, my number, and set that to 1. And then as long as that number is less than 5, we're going to log current and put that current value of that number. This is a thing we haven't looked at before. This is a newer way to use JavaScript strings to combine them with variables. And it's basically the same thing as saying current. In this case, it's the same as saying current plus my number. But the neat thing is that you can then say like something on the other side, blah, blah, and you would need another plus. And it gets a little clunky to be using pluses and to be plussing strings. So you can also use a backtick for your string like this. And you get a string that can have a variable embedded right in it. And you can just pull this example out of the slides if you want to use this method. But basically your variable goes inside here. VS Code should color everything nicely to point out to you that this is not part of your string. This is it's called interpolated into your string. So it will drop this right into your string. So in this case, just kind of remember that this example is the same as doing the one above it. It will have the same effect. And you can see what happens here is that the number starts at 1. It checks, is it less than 5? It is, because 1 is less than 5. So this is true. And so it runs the thing once. And if you notice, the last statement in here is what we've seen in the for loop, where we're actually adding 1 to my number. This again is a shortcut for my number equals my number plus 1. And so the second time it runs, it's going to say current. Well, now it's 2. Actually, sorry. The second time it runs, at first it checks here. And it says 2 is less than 5. Yes, that's true. So it runs again. And it prints current 2, adds 1 again. It's going to check again. 3 is less than 5. That's also true. Runs again. 4 is less than 5. That's true. And it runs one more time. But the next time it says 5 is less than 5, that's false. 5 is not less than 5. 5 is equal to 5. So if you said less than or equal here, it's going to actually print current 5 and then done 5 also. Oh, wait, never mind. Sorry, current 5 and done 6, because it runs one last time and adds one more number to the thing. So, once this is false even one time, then it's done. Then it just stops. It doesn't run the loop again, and it continues. And we used this before in our day 1, in our math problem, I think. Yeah, to say that something was not solved. It doesn't have to be counting a number up. It doesn't have to be any particular thing. It's just something that's either true or false. And as long as it's true, this will keep running. And if you say, while true, it's going to run forever because this will never be false. So if I do that, it's just printing out current and it keeps going and going and going. It's never going to run this. And by the way, VS Code has already dimmed this line because it's detected that it's never going to. It knows this code enough. It's figured out that this can never happen because you have a while true right above it. So this will just keep counting and counting and counting. I'm going to have to press Control C to get it to stop. While false, it's not going to run it even once. It's just going to say done. And by the way, you notice VS Code dims this stuff because it says, hey, this is never going to happen because, it's false. If I do const x equals true and do x, it's not smart enough to figure out that, oh, it's still the same as before. It's never going to be done. But it can't figure it out because it doesn't know that, hey, this is always going to be true. It's not that sophisticated. It actually might be in TypeScript, but we are not going to do TypeScript again. So let's just leave it at that. Yeah, this time, this is also never going to happen, but VS Code it can't realize that easily because it's not quite as obvious. The X is up here and so forth. Okay. Control C to get it to stop. So that's a while loop. That's what those are very useful as well. Oh, I just did this. So while true, this one never finishes. And this code never runs. And you can probably understand why, because every time it checks and it never stops.
Excuse me, Gus, this is Latonia. I just wanted to double check. So the backticks should be used with the while, or should they just be used in general when you're doing
They have nothing to do with the while. They just happen to be introduced in the same example.
Oh, okay.
Yeah. So it's just they have to do with strings. They just are a technique for combining stuff with strings. And what I'll do here is I'll leave the first example here as a concatenation, just so it's, whoops. I need to find a plus that's the right color. See, now I'm not in VS Code. Here we go. Ooh, snag that. Right. Okay. So I'll just leave that. Yeah. So this first example will show the method that you would do with string concatenation. And the second example, it has nothing to do with the while loop being any particular way. It's just to do with the strings. Yeah. But this character is how you do it the way this new technique. And that character is the backtick. It's right next to the 1 key. So yeah, no, thanks for bringing that up, because I think other people might, think that, oh, this has something to do with the particular example. It's just happens to be I forgot to introduce this earlier. So, this is the first time you're seeing it. It's a coincidence. Yeah. Okay. That's while loops. The third one, kind of control flow, we're going to look at is a for loop. And we also saw this in our earlier example. This is pretty straight. Like, this is just describing exactly what it is. So each for loop has a parentheses here that has 3 pieces separated by semicolons. And the 3 pieces are in the first, before starting, it's going to do whatever is in the first piece. Every time it loops, before it loops, it's going to check, just like a while loop, it's going to check whether the second piece is true. And it's going to exit if it's ever false. And after running each loop, it's going to do the part in the third loop. So I'll show you, for example, like how this is very similar to a while loop, but it's sort of like a shorter way to get the same behavior we just did with our while loop. Because we had number being added to by here, number being defined up here. Let me go back a little. So the number is being defined up here. It's being checked in the while loop, and we're doing it at the end of the loop. We're being sure to add to it. A for loop is really just a shortcut way to do exactly the same thing. We're defining it right here. We're checking it in the middle, and we're adding at the end. And so you don't have to do all of that. I mean, you obviously could say, let I equals 0, and then while I is less than 10, and then at the end of this, I plus plus, and you would have exactly the same behavior as this for loop. So if we run this, we'll see the same thing printed out twice. So current counting up to 9, current counting up to 9. The for loop just is a nicer, cleaner way to do the same thing. And by the way, it also means you don't end up with a random variable down here that's called I, because that could confuse you. That could be used somewhere else in your program. If we log I down here, it's going to be sitting around. It's going to still be existing, and it'll be 10 here, because that's the first time this was false, is when I is 10. So it'll linger around forever, and it might get in the way sometime later on. It might have some surprising effect on your program. So generally, if this is the pattern you end up doing, defining, checking, and counting right here, or really defining, checking, and changing it all, like this could be, alphabetized, checking. If this is the pattern you find yourself using, it's cleaner, and you're using this nowhere else. You're not using the I anywhere else. It's cleaner to just put it all into a for loop like this. So if we, for example, if we now delete this and we just have our for loop, well, now it errors because there's no such thing as I. I is not defined. That's good in this case, because we're not using that I for anything other than looping. And it's nice that at the end of all of this, we haven't created some random ghost I variable that we forgot about, So that's all a for loop is it doesn't have to be counting. This part doesn't have to be a plus plus type of thing. It often is. But it really just means define something, check whether something is true, and change something at the end. And so that's it. That's really all there is to a for loop. Now, there's a couple of keywords that we haven't looked at that work for both for loops and while loops. So I actually don't even have a note about the other keyword, the continue keyword, but here's an example of what's called a break keyword. So let's put this in. If you're in the middle of a loop, a for loop or a while loop, and you want to say, okay, far enough, don't even check the next thing, don't run the next thing, just stop right here and exit the nearest loop. You can just say break. And break is going to find the nearest loop, and it's going to stop immediately, and it's going to go to the next thing. So in this case, you notice we still have, we're defining the I as starting at 0. We're checking whether it's less than 10, and we're adding 1 each time. So this should count all the way up to 10, and we should see 0 through 10 here. But inside our loop, we have a break keyword if I is exactly equal to 5. So inside here, once we get to the 5th iteration, this is going to be true, and we're going to run break. So we're only going to see 5 printouts here. 0, 1, 2, 3, 4, 5, then it's equal, and we break. Now, it doesn't even finish the loop. If we put the console.log down at the end here, we're not going to see that 5th one because it will have broken right before it logs, before it logs anything. So that's what break does. Break just interrupts the loop immediately and exits the loop. The other one that I don't have in the slides, but I should probably have included, is called continue. Continue is a little similar, but all this is going to do is say stop this one execution of the inside of the loop and go to the next time. Don't break out of the loop, don't stop the loop entirely, but don't continue inside the loop. So what'll happen here? Can anybody guess what's going to happen if we put continue here instead of break? It's going to be, it's tricky, but let's see if anyone can get it. Skip 5. So it's going to print 0, 1, 2, 3, 4, and then 6, 7, 8, 9, 6, 7, 8, 9, and then done, right? Yeah, I think that's right. Yeah, so we see 0, 1, 2, 3, 4. When it's 5, we continue. So we immediately say, okay, just go to the next loop. Don't run this, and it doesn't print 5. And then we continue to the next loop, 6, 7, 8, 9. And then the 10th time, of course, this is false. So it says, okay, nope, I'm done. And then we see done. So those 2 keywords inside of loops allow you to control, basically, they're a little tricky because they can be hidden somewhere, and you will be like, someday you'll be like, why isn't my loop running? Why isn't it finished? And it'll because there's a little break somewhere tucked away. So be a little careful with them, but they can be very useful to make like a cleaner expression of like the cases where you want to say, okay, I'm done. We don't need to loop anymore. Or, don't bother running this version of the loop because, this number doesn't matter, whatever. That's what continue would be for. Okay. And the last one, this one's a big one. And you'll see this if we do React and Redux and reducers, they're often of this form. And this is just a similar effect as it's called a switch case statement. And you notice there's still a break keyword here. And this one's a little tricky. I don't know if I would always recommend it. There are some programmers who say you should just never use this because this one's a little tricky, but it's like a cleaner way to if you have a whole stack of if, else if, else if, else if, else. It's sort of like a cleaner way to represent it. So the way this one works is you have a big block. It starts with switch. You have, it's not a true false in here. It's any value. So it could be an expression, but you know, it has to reduce to one value in here. And then you have your whole block here, and inside your block, you write these things that say case 1, and then it's stacked right on top of case 2. And this means it's going to check whether the thing in here, the value or the value of the expression in here matches every single case. So is it equal to 1? Is it equal to 2? If so, it's going to fall through to right. It's going to fall down to right here and run the code. And by the way, it's then going to keep running the entire statement until it encounters a break. So this is why this one's a little tricky. If you forget a break, it's going to do some weird stuff. So first we'll just show this demonstration. My number is 5, and it's going to print something else because it will say, is it 1? No. Is it 2? No. Skip. Is it 3? No. And then default is it anything else? And it will run what's in here. This one's a little more tricky. You're not going to use this very much at first. And honestly, unless you have a whole stack of if, else, if, and it's getting unwieldy, I wouldn't bother with it because it has some really tricky parts to it. You have to remember to put a break at the end of everything. And I don't know if you remember the Heartbleed bug that people were talking about. It was like web security. A bunch of websites got, web servers got, you know, they were leaking secrets. They were leaking passwords and things. And that was related to somebody forgetting to put a break statement here. So here, let's say my number is 2. And if we run this, we'll say it's 1 or 2 because it has checked 1, no, and checked the next one, 2, yes, 2 is equal to 2. So it's going to run this code, and then it's going to break, which means it's done with the entire switch statement. The weird thing is that if I say forget to put the break here, it's going to say it's 1 or 2, and then it's 3, even though it never matched this one. And this is why you don't want to use these very much. And I'm just showing them because this is another control flow construct, and you will probably see it for React reducers, which is a little controversial, but it's the convention for doing a one particular thing when you're making a React web page. So you will probably see this at some point, but I don't recommend just reaching for this right away. Unless you really know what you're doing. If you want help with it, of course, like usual, reach out to a teacher or TA, but start with if, else, and see if that gets you what you need. Okay, so that's all we have for control flow. I just wanted to, there's one more topic. We could do a breathing break and just pause for questions. There's one more thing I wanted to cover before we do a little code example today, and that'll be it for today. So how's everybody feeling? Is there any of the control flow stuff that you want some more details on? Let me know now. Otherwise, I'm going to do a little breathing for the next minute. 4 seconds inhale, 4 hold, 4 seconds exhale, 4 wait. All right. Okay. So I added this continue slide. So this is a little more, and this swaps the console log to the bottom because otherwise the continue wouldn't even have a point. You're continuing anyway because you'd be at the end of the loop. So I have to put the log down here for the continue to even do anything. Okay. There's no questions. Nobody needs more of a pause. Let's do a little intro to functions. Now, this is the last very basic fundamental we're going to cover today. We are not going to even, we're just scratching the surface of what functions are today because I feel like everybody's pretty much at their limit of new concepts. If I'm wrong about that, let me know, but I'm pretty sure this is about as much as we should be doing in a day. But first, let's just talk about functions. You've seen some functions in some of our code. It's the keyword function and then a bunch of stuff. Functions are a way to wrap up a small piece of your program. And most functions, not all, but most functions have a name. You want to give them a name that describes what that piece of your program is doing. And it's really the best way that you will be able to take a complicated program and start to break it apart and organize it into more ergonomic pieces. And once you write a function that solves some small part of your program, you can kind of let go of your understanding of how you did that one piece, because you're never going to be able to understand all the parts of your program all at once. So once you've solved one piece and you've named it, then you can just start referring to it by, oh, whenever you need to run this piece, you use the name for it. Some possible names, like you could write a function like we did for our dice game that's just called roll dice. So we figure out the part that rolls the dice. We take those lines of code, we package them up in a function, and we name it the name roll dice. And then everywhere else in our program, we don't have to think of it. We don't have to remember, oh, what do you actually do to roll the dice? The math random, the +5, the this thing. Once you've solved that, all you have to remember is, I want to roll the dice. I'm going to call the function called roll dice. And it's like the most powerful way to build these layers of abstraction, which are going to allow you to make a more complicated program. So you could have one called roll dice. You could have one called save game, which is going to have a side effect, by the way. That's the thing about functions. They can either have side effects or they cannot. And you generally want to prefer them to not do anything other than return some value after they process stuff. But a save game function would probably, you'd want it to have a side effect because that's what it's supposed to do. It's supposed to cause your game to be saved. I'm going to forget about the side effects until later. We're going to talk about that later. So, but the thing you want to take away is functions let you sort of like just package up pieces of your program. And then you can stop worrying about the details of what's going on inside the function and start just calling the function by name when you need that piece. So here's an example of a function definition and then a function invocation. So this is how we say calling a function or running a function or invoking a function. Those are all basically the same thing. So we're defining a function called say hello. And this one has a side effect. It actually logs something to the console. And it logs hello plus the name you pass it plus exclamation. The stuff up here is called an argument to the function. And it's this. When you call a function, it could have nothing that is passed to it, in which case these parentheses would be empty, or it can be passed arguments. It can be passed actually many if you put a comma in between them. What the argument does here is it binds whatever you've put here. When you call the function, it becomes a variable that has this name inside the function. So you see how now I have access to this same name that I've passed all the way from here becomes this variable, and now I have access to it inside. So this is how you have functions that can do many different things. And this is how you can have functions that allow you to have variations in their behavior based on what the outer program needs. And managing what those inputs and what those outputs of the function. This function has no outputs. It just has a side effect. It just logs something and returns nothing. Managing, though, the inputs and the outputs that your functions have is really where what is going to matter to the rest of your program. If you have good inputs and good outputs to your functions, then whatever happens inside, it can be as messy as you want it to be. But as long as it's correct, you can forget about how messy it is because your inputs work and your outputs work. And that's all you have to care about when you're using this function. So to avoid, so here, let's do this example. We define our function, which is our say hello function, and we call it right after. It's not the greatest need for a function here. You could just have have a single line of code that's this. And it is the same thing. We're only calling it once, but we could call it many other times. We could say hello, Karen, and everything else. So now when we run this, we say two calls, both are putting this name that we give the function together with the word hello and the exclamation and printing them to the console. So we've packaged up this little bit of logic that sort of says add hello and add punctuation to it and then print it to the console. And we've given it a name called say hello. And so now everywhere else in our program, all we have to remember is, oh, I want to say hello to this person, so I will pass this argument to the function and it will do the rest. This is what I mean by the side effects. Instead of having it log right inside the function, we can have our function what's called pure. So this function only has, all it does is take inputs and produce outputs. It does nothing else. It doesn't log anything to the console. It doesn't save anything to disk. It doesn't make API calls to another server somewhere. All it does is take some input, do something with it, and return some output. And we use this return keyword inside a function to have it, to tell the function what expression we want to come out of this function. So this works in exactly the same way. The only difference is we're going to run say hello. It's going to return a string because this expression all becomes one string. And we're going to save that string. We could console log just like this, sure. But whoops. Oh, whoops. Yeah, we could log it just like this, but we're going to just save it because why not? And then we will log that variable. So this will do the exact same thing. Whoops. But this function here has only inputs and outputs. Now functions could have multiple arguments. So we could say first name, last name. And we can say first name plus maybe a space plus last name plus the exclamation. And Latanya, this is where, that other kind of string starts to look pretty nice when you have all this plus, plus, plus stuff. But what this will do is allow you to pass in two things, first name and last name. And this will become this will become this, and then we're going to return the whole thing. and then we're going to log it because we've done that. So yeah, we're not going to get too much farther into functions right now. I want to say scope. This is really just saying that for right now, all I'm going to say is if I made a variable const greeting, hello, and I do return greeting plus that plus this plus this plus this, it's still going to work. Oh, whoops, I shouldn't call this greeting. Salutation. I've already used the word greeting. It's going to get confusing. Salutation is hello. So salutation, comma, first name, space, last name, and then exclamation. And it still works. This variable is scoped inside this function. It only exists inside this function. That's all that I want to talk about today about scope. So if you're inside a function, if you're inside an if statement and you do a const something, it's not going to exist outside that the brackets that define the boundaries of your thing. So if I do console.log salutation, well, VS Code might know this already, that it doesn't. No, it doesn't. But it's going to error because salutation only exists until the end of this function. It doesn't exist anywhere else in the program. So it is effectively scoped to inside the function. And this is another powerful way to kind of like be able to reuse the same words and not have them get confused with each other. If you keep them inside the scope where they're relevant, then they don't exist outside of that. So you could have, you know, a salutation here. You could say bonjour, and our salutation in here would be bonjour. And I can talk about the salutation in both contexts. I don't know if this doesn't really actually make sense, but you get what I'm saying. You can have two different contexts that have two different variables that are the same. And this helps if you want to use an I to iterate, or if you want to use something, you know, a common word inside your program, because you don't want to write a long program, but you'd like it to stay scoped to just where you need it. That's the last thing. So let's forget about blocks. Let's do the rest of this later. Yeah. Yes.
So if they put the console.log of the salutation inside of the scope, then it will register, right?
Then what will register?
If you take the console.log of the salutation and put it inside of the scope.
Yes. So if I log, oh, whoops. So see, it dims this because I'm already returned. Functions don't keep going after you return. They can only return once. So I need to put the log right here. So salutation, I'll log in both cases and say hello, and then I'll log the greeting because this variable is scoped outside. This exists outside the functions. But if I do here, it's going to log my salutation right up here, and then it's going to log my greeting down here. And it's fine because in this scope, yeah, the salutation variable exists in this scope. And if I do say bonjour, I'm going to get bonjour, and then the greeting will also use that because it's run this code here. Okay, so if this last part is really confusing, we're going to go over this a whole lot more in more detail, and we're going to talk a whole lot more about functions in general. So what does it mean when it returns nan? Nan is not a number. So yeah, so if I go to node again, if I just go to my node loop and I say 5 plus true, JavaScript helpfully converts true to 1. What if I do 5 plus object? Oh, it converts both to a string. How do you get a nan? Like, not a number. Parse int, not a number. Not a number. That's not a number. So if you try to parse an integer with like something that is not a number, that's nan. It's just a special kind of number. And it's a special like type, I think. It's almost a type. Oh man, this is where we should watch. I'll post a video if you want to see all kinds of nonsense with nan, but it's going to not be your friend, basically. Nan means you messed up somewhere and you tried to do math with something that isn't going to be able to do math, or you tried to parse something that isn't actually a number. And now JavaScript has given up. It will still try to run your program. It's not going to error, but all your numbers are going to turn into nans, because if you do nan plus 5, that's also nan. So it sort of like spreads like a virus. It goes everywhere. It means you accidentally did something that would require it to be a number, and it's not a number. Would you mind pasting the code where you got that? Oh, thanks. Yes, let's see what exactly it was. Return. You have some extra commas, and I don't even know how that ends up nan. That's interesting. Those 2 commas on your second line there, you got to get rid of those, because and then it should work. Man, that's interesting. You somehow you've convinced JavaScript that that's valid, but somehow that all ends up as nan. Let's try to figure that out. Okay. Honestly, I don't know. It's confusing. I'm going to post in the student channel. I will post a fun video. Gary Bernhardt what video? This is pretty classic, like just making fun of all the weird stuff JavaScript does. So if you want to see a whole lot more examples of weird nonsense values showing up in nans, and it's going to be, this is like a horror movie for people in your situation, I think. Everyone just trying to learn JavaScript. So only watch if you have a strong stomach, but it's also pretty funny. It's like classic, JavaScript is going to be JavaScript. It's going to be weird.
All right. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone.
So yeah, it's all kinds of stuff like that. If you an empty array plus an empty array, it's an empty string for some reason. And there's a million of these. And again, it's gonna probably scare you, but yeah, definitely like reach out for help. I was able to recognize the problem in your code. I'm not sure why it exactly is not. And we could try to figure that out, but I think we should try to do a code example so everybody's ready for the homework. Maybe let's, I'll poke around. Maybe I'll have an answer for you tomorrow for exactly why. And it might be a very confusing answer, so we'll see. Okay, we got to get to our code example. So our code example today is just doing some stuff with prime numbers, and we're going to use the modulo operator, and we're going to check whether numbers are prime. So if you go to the W6D3 folder, let me exit out of Node because I have this caret here. So Control C, Control C. I'm in the right folder. I have W6D3 prime numbers. Again, you can do Control click on the folder, open an integrated terminal if you don't have the right terminal here. And we're going to open the primes before file. And Gee, I have some like changes. I'm just gonna close it. I don't know what those are. Okay. So this whole section here, this is called a sieve of Eratosthenes. You don't need to figure out what this is doing. This would take me a long time to figure out what it's doing, but basically what it does is it goes through all the numbers between up to this maximum, and it pulls out the prime numbers. So what it does is it starts with an array of a bunch of trues where the position in the array is the number. And then it goes through and checks whether stuff is prime. And this is a classic kind of elementary school math thing about prime numbers, where basically you say 2 is prime. So now go into your list of numbers and mark off every multiple of 2 is not prime. 4 is not prime, 6 is not prime, 8, 10, 12, 14. Okay, you're done with the 2's. Now do 3. 3 is still prime, yes, okay. So now mark off 6, 9, 12, 15, 18, every multiple of 3. Okay, now go to 4. Oh, 4 has already been marked because it was one of the 2 numbers, so skip that. Go to 5, and then it's like an efficient way to find prime numbers through this process. So basically, all I want to say is that this has some clever stuff that you could try to figure out if you want, but it might be beyond everybody to understand all these parts right now. Probably by next week, you'll be able to pick some of this apart. This is going to return an array full of just the prime numbers up to some maximum. What we want to do is check whether this is true by writing a new function that tells us whether a given number is prime. So you pass it a number and it returns true if it's prime and false if it's not. And the example I have here is definitely not correct, because this is going to say every number is not prime, which is not true. Some numbers are prime. So I'll get rid of all of this, I guess, and let's just say const console.log is prime 3. So we're going to execute the is prime function, pass it the number 3, and then the return value of that will be the value of this expression. And then we're passing that to console log, so we'll log it out to the console. So we're going to log whether 3 is prime. We're going to log prime 6. So 3 is prime, by the way, is a prime number, and 6 is not a prime number. So we should see true, false. Problem is, if we do node primes before, it says both are false, of course, because our function always returns false. You could say is prime not even a number, and it will say false. I mean, which is actually right because it's not even a number, but that's beside the point. What we want to do is fill in the rest of this function so that it's correct. Now, how do you check whether a number is prime or not? A number is prime if it divides into equal parts, some number of equal parts. So the textbook definition is if it's divisible by anything other than itself or 1. Obviously, you can divide anything by 1. That's silly. Like, it's the same number. 10 divided by 1 is 10. That's silly. Prime means you can't divide it into any number of equal parts. So you can divide 10 into 2 parts of 5. You can't divide 11 into any equal number of parts. So that's a prime number. And we can do this, we can check this pretty easily by using our basic control flow structures. What we need to do is count. We can just go through each number that could divide into this number and use our modulo operator to see whether the remainder when you divide it is 0. If the remainder is 0, it divides evenly into that number. If it's anything but 0, it does not divide into that number. So we can combine those to make our function that checks if any number is prime. And we'll do this by starting with a for loop, because this is how we would count through and check each number in sequence. And we'll do this with the normal thing you've already seen. Let I equals 0, semicolon. I is less than number. We'll change that in a second because that's not totally necessary, but I plus plus. So we'll check every number up to that number. And basically, what we're going to say is if number modulo I. Carolyn, don't worry about it. I told you don't worry about it. This is the map that we're not, the comment clearly says, don't worry about how this works. It's a bunch of super clever math and JavaScript. We're not going to talk about it today. We'll talk about it next week. This is, so, okay. So we loop, we check every number up to that number. Obviously, a greater number couldn't divide into our number. So we only have to check up to that number. And we don't even have to check up to that number, but I'll talk about that in a second. If our number modulo the current I, the thing we're counting up, is 0, then we know it divides. If this is true, we run the thing in here. And what we can do in here is say return false, because something divides into it. So it's not prime. And then all we have to do other than this, now this is not quite correct yet, but we're getting close. All we have to do other than this is if we've gone through our whole loop and we've looped all the way up, then we return true because nothing has divided into it, because we know this code hasn't run, because if it did, the function would exit right away. We would have our return right away. So we know that if we get down to here, nothing has divided into our number, so it must be prime. And this is pretty close. There's a couple problems with this, but let's see if it works for our two candidates here. So I'm going to save. And I will say node, and it says false, false. That's not good. Let's think about what's happening here. So let's just trace this. I starts at 0, and 0 mod number, or sorry, number mod 0. So what is 3 mod 0? Because when we pass 3 in, that's our number. And we're doing number mod 0 first. And if we go back to node, we can see 3 mod 0 is not a number. So that's not good. You can't mod by 0. Well, we shouldn't start at 0. Let's start at 1 maybe, because that doesn't even make sense. You can't mod anything by 0. So 3 mod 1, let's check this in advance. 3 mod 1 is 0. That's not good either, because remember the definition of prime is it's divisible by anything except itself or 1. So everything is always going to mod to 0 by 1. So we need to start at a 2 actually. Let's try 3 mod 2. That's not 0. That means that's good sign because we know 3 is a prime number. And so we should be starting at 2. The other 2 are special cases. We shouldn't start counting it at 0. So we're going to start our loop initializing I to be 2. So the first time it checks, I is going to be 2. So 3 mod 2, this one should work. There we go. True, that one's prime. False, that one is not prime. Okay, let's add a couple more tests. 7. true, false, true. That one is prime. I think we're looking pretty good. 11, 12, 13. True, false, true. 11, 12, 13. Prime, not prime, prime. This is good. But what if we do 1? The first one is true. 1 is prime. That's probably okay. What about 0? Is 0 prime? That's not even well defined. Hey, this seems to work all right. What about 2? I guess 2 technically is prime. It never runs the loop because 2 is not less than 2, but that's okay because 2 is prime. So our function looks pretty good here. The only other thing we might want to do is, make sure the number is really a number. We won't really bother with that right now, but we could make sure the number is really a number, an error otherwise. We could make sure the number is 0 or positive, or probably 1 or positive, because you can't really say like 0 or -1 is a prime number. That doesn't seem to make a whole lot of sense. Maybe. I don't actually know, but who cares? The only other thing we might want to do is that we don't have to check all the way up to the number. We know that if we have gone up to the square root of the number, then there couldn't be any factors that we haven't checked, because like if you're checking whether 10 is a prime number, you check 2, that divides. You check 3, that doesn't. You check 4, that divides. You check 5, that divides, but it divides with 2 because we've already passed the square root. So anyway, for the math reasons, we don't really have to check all the way up to the number. So that's why in the after, I have it less than or equal to the square root. Oh, also I have it saying 0 and 1 are not prime, which I don't even know if that's correct. Let me look it up, because honestly, I don't know. Is 1 prime? No. Okay, so you need a special case here. Anything lower than 2 is 0. No. Is -1 prime? -2? So nothing negative. Okay, so if number is less than 2, it's not. Okay, that's right. We'll copy this little bit right out of our after because we'll cheat a little bit. We're running out of time. So anything less than 2 is technically not prime, because I don't really know why, but that's what the math people say. And we can do less than or equal to math.square root. This is how you do the square root. Because of the way that the factors work, if you get up to the square root and you haven't found anything, you're not going to find anything after the square root either. So we can stop checking right there. But if you don't realize that, it's totally fine to say less than number. It's just going to use more computer power. That's totally fine. In most cases, the computer's fast enough where it doesn't really matter. Okay, so that's really the whole exercise for today, is that we're checking that any numbers divide into our number, and we can use all of these combinations to check whether stuff is prime. And then to test all of this, the only reason I have all the code in the top, I mean, number one, if you are curious, some people might want to poke around. I am telling you officially, do not worry about it. But, someone's going to poke around in it, and that's okay. But we really just want to grab all the prime numbers under 100 and just double check that our function works. So here I have all of this gives me a list of all the primes up to 100. I'm just sanity checking here. Is prime 100? 100 is not prime, so it should say false. And then I'm going to log all of the prime numbers. Here's a map. Oh no, Carolyn, You're right. I didn't put a don't worry about map. It's an array thing. It turns this array into a different array using a function to transform it. And don't worry about what that means if that doesn't make sense, because we will get into it later. But this is going to print out a list of what our function says for each of the prime numbers. It should say true for all of them because they're primes. And then we're going to log the original numbers just so we can look at them. Sorry about that. I thought you were talking about the map up here. Sorry, but still the answer is the same. Don't worry about it. Yeah, sorry. Okay. So false, 100 is not prime. True, 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 true. All of our primes that we found are prime. And here they are. So our is prime function seems to work well. And it's basically the same as the other one. It just uses this little square root trick in the after one. Okay, yeah, I don't have, I don't want to saturate people. Don't worry about this. We'll go into this later. Sorry for putting it in here. I'll rewrite this in a nicer way if anyone wants to hang out. But otherwise, thanks for coming by the class today. Hope it was not too much stuff. Hopefully this example helps you with the homework, because you're going to have to check whether things are divisible by things to do the homework. And you're going to have to use for loops, or no, I think if, yeah, you're going to have to use for loops and if loops and things like that to do the homework. So good luck. It's not that hard. There's really no giant trick to it. It's pretty tricky because it's a big step up. It's like the first real program that people are writing. So, you know, don't worry too much if it's hard. It's going to be the first big step up. And please come with questions if you get stuck on it. Everyone's looking at me like a zombie because I just whacked you over the head with a bunch of prime number nonsense. Sorry. Yeah, probably don't know if I should have done that. Anyway, yeah, the
I'm
homework.
just having the after effects from my second Moderna that I got yesterday. It's been a rough day, but I made it through class. Kind of, I don't know how much I absorbed, but I've got videos of, so.
Yeah, so the slides, I mean, just treat them like a reference. You should really not have remembered most of the stuff in the slides today. There's so much stuff. I hope some of the descriptions when I'm talking about the, you know, what is an expression evaluates to true or false. Like that's really the important things to start to try to understand. Everything else is maybe a little too much, but anyway, thanks for sticking with it, everyone. Get some sleep.
Sent you a screenshot in Slack. I direct messaged you, pinged you, whatever, of what I started doing on last night's homework to see if I'm even close. So
Okay.
you let me
good.
know, and then I can go through this stuff. And then I renumbered the homework so that they're in line with, so I resubmitted the homework part of 19. So there won't be confusion anyway.
Yep. And yeah, Alina and Karen, that's right. This is probably the worst mathy week of the entire class. So it's going to get confusing. There's going to be confusing concepts, but it won't get worse math-wise. So just, you know, it's a little exercise for like, but I think, yeah, I could have maybe chosen better examples. But it's really hard at this point when we have so little to work with. There's not much else we can do with the programming yet. So thanks for bearing with me. Yeah.
Oh, you're great. Thank you.
All right. Have a great evening. Unless you want to stick around and ask questions, I'm going to stop the live stream. And
not that I don't want to, but I got to go lie down.
yeah, get some sleep.
Thanks, Gus. See y'all tomorrow.